Good morning, y'all. So we are all done with the SI system, the System International, the units we're used to. Now we're going to start talking about the Imperial system. That is the system usually seen as used by the Americans. Okay. Fun fact: this system of weights and measures was first defined less than 200 years ago. Right? That means it's relatively new in the world of math. New doesn't make it good, just makes it new. Right, so we're going to start by talking about length. So if you want, you can try this. Trace your foot or shoe onto a piece of paper, then determine how many thumb widths it takes to be the same as your foot. So you could go ahead and pause this, or you could just measure out how many thumb widths it takes. 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, apparently on mine, just by guessing, mine works out to approximately 13 thumbs in 1 foot. Now, this is no coincidence. We should all be fairly similar, right? It's because in the imperial system, we actually use feet as a unit of measurement. And we'll find that 1 foot in the imperial system is 12 inches. Inches are like thumbs, feet are like feet. All right. But we'll come back to that in a second. So, in the imperial system, units are usually split up into twelfths or sixteenths, not like the SI system where everything is divided nicely in powers of 10. So, because we're going to be working with twelfths and sixteenths, we have to polish up on our fraction skills. So this is something we haven't done in a while, probably, is adding fractions. So when we add fractions, we need to have a common denominator. That means this bottom number has to be the same. Right now I've got a 4 and an 8. They're not the same. I can't add them. So I need to multiply top and bottom to make these numbers the same. Right? So what do I need to multiply by 4 to make it an 8? What do I need to multiply that by? So I need to multiply that by 2. But whatever I do to the bottom of that fraction, I got to do to the top. So now I'm going to rewrite this. So 3 times 2, well, that's actually 6. And 4 times 2 is 8. And my other fraction is still 5 over 8. Now that these bottom numbers are the same, I can put these two fractions together. So now on the top I've got 6 plus 5, and the bottom stays the same. 6 plus 5, that equals 11. And my bottom number stays the same. So that is my answer. Same idea when subtracting fractions. However, with your multiplying fractions, you can just multiply the tops and the bottoms. All right, some quick history. I'll read this to you. So, you discovered that there were about 12 thumb widths in a foot. The Romans also divided their foot into 12 parts. The word inch actually comes from the Latin word unitia, I think that's how you say it, which means a 12th part. In some languages, the same word is used for thumb and inch. So for example, in French, the word for thumb and inch is both, I want to say pouce, pouce? Whatever. Anyway, that French word. Right. The Saxons were people who settled in Britain after the Romans left. The Saxons used 3 grains of barley placed end to end to define their inch. All right, so picture 3 grains of barley. 3 little grains of, grains of grain. Barley seeds were very, very uniform in size, not like everyone's thumbs are different. The Saxon inch, which is 3 units of barley, is very, very close to today's inch, but it was longer than the Roman inch. So as a unit of measure, the Saxon foot, which was still 12 inches, was longer than the Roman foot. So that led to a problem that was faced by many, I guess, cultures when trying to communicate. Right? So when a Saxon says a foot, it was actually bigger than when a Roman said a foot. So later it was redefined, and today it's actually based off of centimeters. So today's inch is exactly equal to 2.54 centimeters, which you'll find on your formula sheet. So the different ways we actually write inches and feet, we can write 1 inch as 1 inch with 2 quotation marks, and we can write 1 foot as FT, or we can write it as, I guess that'd be 1 quotation mark. All right, so get used to both ways. All right, let's talk about measuring and reading rulers. This is very, very common in construction because everything still uses feet and inches in construction. So when you're reading a ruler or a tape measure, each of the smallest ticks is usually, most of the time, is 1/16, usually. The better way to look at it is in halves. Okay, so I'm going to use purple first. So if I break this inch, if I'm just looking at the first inch, this longest one is a 1/2 inch. This, if I cut that in half again, that's a 1/4 inch, which means a 1/4 inch less than 1 would be 3/4. Then if I cut that in half again, a half of a 1/4 would be an 1/8. So this would be 1/8. A 1/4 is 2/8. This would be 3/8. A half is 4/8. 5/8. 3/4 is 6/8. This one would be 7/8. Ooh, that's sloppy. 7/8. And then we could further break it down into 16ths, which is what all of these little notches would be. Okay, so you're going to want to familiarize yourself with being able to read in 16ths, eighths, quarters, and halves instead of the decimal system that we're used to using. All right, let's get right to it. Let's get doing some converting, some math. So in this example, we're looking at an Iroquois longhouse with 79 feet and 11 inches long. I want to know the length in just inches. So right now I'm 79 feet and 11 inches. So I'm going to do this with a skeleton equation because that's what I like to do. However, I'm not going to convert this whole number. This is already in inches. So I just need to convert this part, the 79 feet. So I'm going to put my 79 feet in the first one. And I know from my formula, or from the previous slide, that 12 inches is the same as 1 foot. So this number here is going to be 12. And I want to change my answer into inches. So because I'm changing into inches, which is smaller, my number has to get bigger. All right, so I need to do 79 times 12. 948. But I'm not done. That's just what the 79 feet was. This longhouse was 79 feet and 11 inches. So my answer, I've got to add those 11 inches again. So I've got 948 inches plus 11 inches. That should give me 959 inches. If you don't believe me, let's double check. 948 plus 11, 959. Ta-da! Okie dokie. And, oh, let's do one more. Let's work backwards. So, in this example, Merlin is 53 inches tall, but nobody ever says their height like that. We always say our height as a combination of feet and inches. For example, I always lie when I say my height. I always say that I'm 6'2" because I want to feel tall. So I want to change it into that kind of style. So into some number of feet and some number of leftover inches. So basically, we want to know how many full feet there are, and this is the leftover. So this number here is going to be less than 12. Because if it was bigger than 12, it would be a full foot. All right, so we can do this a couple ways. Let us pretend that let's try to convert it straight into inches. So I'm going to do my skeleton equation. And I'm going to convert 53 inches into feet. So I'm going to divide by 12 because I'm going to a bigger unit. So 53 divided by 12. 4.41 and a bunch of sixes. 4.41 and a bunch of sixes. So I just want to know how many full feet there were. So I'm just going to look at the first bit here before the decimal. So that's how many full feet I have. The rest is the leftover. All right, so this is going to seem kind of backwards, but we're going to change this back into inches. So I've got 4 feet, and there's 12 inches in a foot, and now I'm going to change it into inches. So this number is going to get bigger again. So I'm going to go 4 times 12, and that'll give me 48. So this is the same as 4 feet. So to figure out the leftover, I'm going to take my original height, my 53, and I'm going to subtract my 4 feet, which I know is the same as 48 inches now. So 53 minus 48, and that was inches. And that should give me 5 inches. Right, so my answer is 4 foot 5 inches. Right, and that is my answer. All right, let's do 2 more examples and then I'll call her a day. All right, so in this example, we're talking construction here. So when we use 2x4s, they start off as 2x4s. They start off as a block of wood that is 2 inches by 4 inches. That's how they start off in life, but they're really, really rough. So what happens is they plane it or they sand it. So when they sand it, they take some off of both sides, and or from all sides. And you're just left with that middle piece. So this middle piece here, it's all nice and smooth, but it's not a 2x4 anymore. So it's actually a little rectangle that is 1.5 inches by 3.5 inches. They plane off a ½ inch. All right, anyway, let's look at the actual question. So John and his mother are finishing their basement. For the outside walls, they plan to use 2x4 framing lumber. Framing lumber is sold as 2x4 pieces is actually 1.5 inches by 3.5 inches. The lumber will be covered with a gypsum board measuring 3/8 of an inch. Pardon me. So how thick will that wall be? So as you can see, they got the board here, and then they have the gypsum board, which is 3/8 of an inch. So we want to know how long this entire side is. So what we're actually going to do is we're going to add the long side to the 3/8. So we're going to add 3.5 plus 3/8. So I've got a couple ways here. The easy way is if you can picture it to use a ruler. Okay, so remember we're using inches, so we're going to look at the bottom. So my 2x4 we said was actually 3 and a half. So that would mean it comes to here. And I've got to add 3/8. So from the beginning, we said that eighths were, okay, so if this is a half, then this is a quarter here. So eighths are these ones, these medium ones, not the smallest, the second smallest. So I got to add 3 of those. So 1, 2, 3. So it's going to be right there. So now my total length is 3.5, and 3.75, and one more. So that will be, well, it's 1/8 less than 4, so that will be 3 7/8. Okay, so I know my answer just by looking at the ruler. It's going to be 3 7/8. But let's do this the mathy way instead. So I'm just going to erase all this, give myself some room. Now when we're adding fractions, we said before we have to have that common denominator, but we can't deal with this mixed fraction. We have to make that into an improper fraction. So in order to do that, to change my 3.5 into an improper fraction, I'm going to take this number, times it by this number, so I'm going to times it, and then add it to this one. So what that looks like as a fraction, my bottom number is going to stay the same. The top number is going to change though. So I'm going to go 2 times 3 plus 1. So 2 times 3 is 6, plus 1 is 7. Right, now I'm going to add my 3/8. Oh no, I need my bottom number to be the same. So I need to do something to this 2 to make it the same as an 8. So I need to multiply it by 4. But whatever I do to the bottom, I do to the top. So now I've got 2 times 4 is 8, and 7 times 4 is 28. Now, and I have my 3/8. Now I can just add it. 28 plus 3, that's 31/8. Well, that doesn't look like the same answer. I said before that my answer is supposed to be, over here I said that it's supposed to be 3 7/8. But this is a mixed, this is an improper, so we can change it back. So I need to know how many times 8 goes into 31, or 31 divided by 8. So if I'm lazy, I'm just going to use my calculator because I am being lazy. I'm going to just see if it works out perfect. 31 divided by 8. No, it doesn't work. It's 3 and a little bit left over. Alright. So we're going to use that. So there's 3 full things and a little bit left over. So when I'm changing it, 3 and something left over. How many left over? Well, this part here, this 3, is the same as, I'm going to show an extra step. This is the same as saying, well, that 3 plus 3/8. Not 3/8, 7/8. So I'm just kind of working backwards here. So we said if the common denominator is the same, we can write it as 2 fractions. Kind of the opposite of what we did up here. So now 24 divided by 8, I know that that is just 3. Okay, so this part here is the same as 3. And 7/8, well, that's as good as it gets. So I'm going to leave it as 7/8. Okay, so this 24/8 goes there. Okay, same answer, same answer. Okie dokie. And one more. Sorry, this is a long video. So, a desk is 2 foot 9 inches in width, and it's pushed against a table measuring 5 foot 6 inches. I want to know what the total length in feet and inches is. So picture, I've got 2 desks, and I want to know what the full distance is. I'll draw this a little bit more realistic. Okay, we had one big one and one little one. So the little one is 2 foot 9 inches. The big one is 5 foot 6 inches. All right, so when I'm going to add these, I can do a couple things. I'll show you both ways. I'm just going to add it as if I was, yeah, just normal adding. So first I'm going to add the feet, then I'm going to add the inches. So 5 foot plus 2 foot equals 7 foot. 7 foot. And 6 inches plus 9 inches. My answer will be 7 foot 15 inches. But one of the earlier slides, we said that this number can't be bigger than 12 because that's a full foot. So we're going to take that that full 12 and we're going to write it as a foot instead. So I actually have 8 feet and 15 minus 12. So I subtracted 12 and I put it over there. Is going to give me 3 inches. And that's my answer. Okay, that's probably the quickest way, but if you don't like it, I'll show you another. Alrighty, so let's change everything into inches. Alright, so let's first deal with this 5 foot 6 inches. So, if you're a big fan of skeleton equations like I am, I'm going to take my 5 feet and change it into inches. I'm changing into a smaller unit, so that means I'm going to times. 5 times 12 is 60. Right, so my first table, well, it's more than 5 foot, it's 5 foot 6. So it is 60, which is my 5 foot, plus my 6 inches is 66 inches. All right, that's my first table. My second table, I'm going to do the same thing. 2 foot times 12 is 24 inches, but I was 2 foot 9. So my 24 plus 9, that should give me 33 inches. Now we're adding them, so I'm going to add my 2 tables. Next step here. Take my 66 inches plus my 33 inches. That works out really well to 99 inches. But we wanted it in feet and inches, so I wanted it in how blank feet and blank inches. So now I'm going to try to change this into feet. So I'm going to use another skeleton equation. Alright, so I'm starting with my 99 inches. And I want to change it into feet. So I'm changing into a bigger unit, so I'm going to divide by 12. Let's go to our calculator. 99 divided by 12. 8.25. Okay? 8.25. But I want to know it in feet and inches. I don't want this decimal. I've got to have whole numbers. So I'm just going to take the 8, just the first part. I'm going to change it back into inches. So 8 feet times 12. 8 times 12 is 96. Okay, I feel pretty lazy on that one. I should have been able to do that in my head. So that is what the 8 feet is. So remember, if we're doing blank feet and blank inches, I've got my 8 feet. But I didn't have for just 8 feet. I had 99 inches, not 96, 99. So to figure out what that leftover is, I'm going to take my original inches and subtract whatever that 8 feet was, which was 96 inches. That gives me 3. Hey, look at that. Same answer. So one way is longer than the other, but do whichever way you like. Anyway, I'm going to stop talking. This has been a long enough video, and enjoy.